Hello students, welcome back. I am Rinkesh sir and today we'll continue with exercise 6.2. Till our last video we had completed till question number 12. So today we'll start with question 13. Okay, so let's start with question 13. Question number 13. On which of the following intervals is the function f given by fx is equal to x raised to 100 plus sin x minus 1 strictly decreasing? Okay, option A 0 1, option B pi by 2 to pi, option C 0 to pi by 2, and D none of this. Okay, let's start. What is fx? Fx is equal to x raised to 100 plus sin x minus 1. Okay, so now what will be f dash x? 100x raised to 99 and derivative of sin x is cos x. Clear? So now if I take option A 0 to 1, now this is in radian. Okay, now see which is the first quadrant, 0 to pi by 2. Clear? And pi by 2 means 1.57 radian, half of 3.14. Okay, so in first quadrant, this 0.1, sorry, 0 to 1 radian, that will be definitely in the first quadrant. In first quadrant, cos x is always positive, right? This is 100 into positive number raised to 99, right? So that will be positive. So for x belonging to 0 to 1, f dash x is greater than 0. Therefore, increasing function. Okay. Now, if I take pi by 2 to pi, that is second quadrant. For x belonging to pi by 2 to pi. Okay. Cos x is less than 0, negative. And which is the minimum value of cos x? Minus 1. So I can write down 0 less than cos x less than minus 1. Okay, for pi by 2 to pi. Now see, pi by 2 to pi means 1.57 in radian, and here it will be 3.14, greater than 1, right? So x is greater than 1. That means x raised to 99 is greater than 1. Multiply both sides by 100. 100x raised to 99 is greater than 1. Now see, sorry, 100. So you can see here, this will be greater than 100 plus the maximum value of cos x can be minus 1. So what does that imply? 100x raised to 99 plus cos x, that must be greater than 99. Okay, because the minimum value of cos x is minus 1 and the maximum here it is always greater than 100. So this is greater than 0, f dash x greater than 0, so increasing function. Clear? So for option A, no, it is not decreasing. B, no, it is not decreasing. Now I will take option C, 0 to pi by 2. Now when I take 0 to pi by 2 first quadrant, that means 100x raised to 99 positive plus cos x positive. When I add two positive number, it will be always greater than 0. So f dash x greater than 0. Therefore, f is increasing. So C is also cancelled. So D is the correct one. This is decreasing in none of the interval given in A, B, and C. Clear? Question 13. So just note it down. Now let's move to the next, that is question number 14. Question number 14. Find the least value of a such that the function f given by fx equal to x square plus ax plus 1 is strictly increasing on interval 1 to 2. Okay, so now what is fx? Fx is equal to x square plus ax plus 1. Okay, now f dash x, that will be equal to 2x plus a. Okay, now see here, for f to be strictly increasing, f dash x must be greater than 0. That means 2x plus a must be greater than 0. That means a must be greater than minus 2x. Okay, now the question is least value of a. You have to find out the minimum value of a. Right now x belongs to open interval 1 to 2. Clear? So I can write it down 1 less than equal to, sorry, 1 less than x less than 2. Okay, here it's minus 2x. So when I multiply it by 2, less than x less than 4, multiplied it. Now it's minus. So multiply by minus, so I will change the sign. Okay, like minus 2 greater than, sorry, it will be 2x here when I multiply it by 2. Now multiply it by minus 1, so minus 2, I need to change the sign. Minus 2x greater than minus 4, or I can write it down minus 4 less than minus 2x less than minus 2. Okay, so see, a must be greater than minus 2x. This is the given condition. So the greatest value that minus 2x can have is minus 2. So the maximum value, sorry, the a must be greater than minus 2, right? So the least value of a is minus 2. Okay, or else we can solve it in different way also, like 2x plus a must be greater than 0. The value of x is 1 and value of x is 2, right? If I take x as 1, means 2 into 1 plus a greater than 0, right? 2 into 1. Clear? So that will be equal to 2 plus a greater than 0. So a greater than minus 2. Now, if I take here a value of x as 2, then 2 2s are 4, right? So 4 plus a, that will be equal to 4 plus a greater than 0. A is greater than minus 4. Now, if I need to take both these condition, means satisfy, if I take any value between 2 and, means minus 2 and minus 4, right, then it would not satisfy the condition. Clear? Like if I take value of x as 1.5, okay, and if I'm taking value here a equal to minus 3, then 1.5 minus 3 will be less than 0. So the minimum value that it must require is minus 2. Okay, so that was about question 14. So write it down. One more thing, it is asked the least value. Now let's move to the next, that is question number 15. Question 15. Let I be an interval disjoint from minus 1 to 1. Okay. Prove that the function f given by fx equal to x plus 1 by x is strictly increasing on I. Now see here, I is disjoint. Means I is the interval, any interval that does not consist this interval. So I can write it down that x does not belongs to minus 1 to 1. Okay, if x belongs to I, so I'm writing x belongs to I, that implies x does not belong to this. Okay, so I can write down x is either less than minus 1, I will write down equal to because open interval it is, or x is greater than equal to plus 1 because it does not belong to interval minus 1 to plus 1. Clear? Now what is fx? X plus 1 by x. So what will be f dash x? X derivative of 1 by x minus 1 by x square. So this will be equal to x square minus 1 upon x square. Now for every x less than equal to minus 1, I will write down x square greater than equal to 1 because when I take square it will become positive. Okay, that means x square minus 1 greater than equal to 0. See, now when I consider this f dash x, numerator x square minus 1 greater than 0, denominator x square greater than 1, that means greater than 0. That means f dash x is greater than 0. And for every x greater than equal to 1, again x square will be greater than equal to 1 because it is positive only. And this means when I take 1 on this side, x square minus 1 will be greater than 0. Again, numerator denominator both are greater than 0, greater than equal to 0. So I will say f dash x is greater than 0. Hence, f is strictly increasing on I. Clear? So this was about question number 15. Just note it down. Now let's move to the next, that is question number 16. Question number 16. Prove that the function f given by fx is equal to log sin x is strictly increasing on 0 to pi by 2 and strictly decreasing on pi by 2 to pi. So fx here is equal to log of sin x. Okay, so f dash x derivative of log is 1 by x, so log of sin x its derivative is 1 upon sin x into d by dx of sin x, that is cos x. So this is equal to cot x. Okay, now cot x is positive in 0 to pi by 2 for every x belonging to 0 to pi by 2, f dash x equal to cot x greater than 0 because cot x is positive in the first quadrant. Therefore, f is strictly increasing in 0 to pi by 2 on 0 to pi by 2. Now, for every x belonging to pi by 2 to pi, that is the second quadrant, and in second quadrant, cot x is negative. So less than 0, therefore f is strictly decreasing on pi by 2 to pi. Clear? So this was about question 16. So just note it down. Now let's move to the next, that is question number 17. Question number 17. Prove that fx is equal to log of cos x is strictly decreasing on 0 to pi by 2 and strictly increasing on pi by 2 to pi. Here it's modulus of cos x. Okay? Because in first quadrant it's okay, it's positive. But in second quadrant cos x is negative. Okay? and we only can take logarithm of, we will take only of positive numbers. So it's modulus of cos x. So now let's take fx is equal to log of cos x. So f dash x, derivative of log of cos x, it's 1 upon cos x into d by dx of cos x, that is minus sin x. So this will be equal to minus tan x. Okay, so now if I take for every x belonging to 0 to pi by 2, tan x is greater than 0 because in first quadrant tan is positive, right? So tan x is greater than 0. That means minus tan x will be less than 0. That means f dash x is less than 0. Hence, f is strictly decreasing on 0 to pi by 2. Now, for every x belonging to pi by 2 to pi, that is in second quadrant, tan is negative. So, tan x less than 0. So, minus tan x, that will be greater than 0. So, that means f dash x is greater than 0. Okay, hence f is strictly increasing on pi by 2 to pi. Clear? So this was about question number 17. Just note it down. Now let's see the next one. That is question number 18. Question number 18. Prove that the function given by fx equal to x cube minus 3x square plus 3x minus 100 is increasing in R. Okay, so now let's see f of x, that is equal to x cube minus 3x square plus 3x minus 100. So what will be f dash x? 3x square minus 6x plus 3. Clear? So now let's take 3 common. It will be x square minus 2x plus 1. So x square minus 2x plus 1, that is the formula for x minus 1 whole square. Now say 3 is greater than 0 and x minus 1 whole square, as it is square, it will be always greater than equal to 0. So this will be always greater than equal to 0. Hence f is increasing on R. Clear? Whatever value of x you take, this will be always greater than equal to 0. Means f dash x. So f is increasing on R. Clear? So this was about question number 18. So just note it down. Okay, that is question number 19, the last for this exercise. Question number 19, the interval in which y equal to x square e raised to minus x is increasing. Okay, so let's take y equal to fx, and that is equal to x square e raised to minus x. Now let's take f dash x. So we will use the method of uv, x square as it is, derivative of e raised to minus x, e raised to minus x into d by dx of minus x minus plus e raised to minus x as it is, derivative of x square 2x. Okay, so what's common here? E raised to minus x and 1x here. Out of here it is x square, here it is x. So x is common. So I will take x e raised to minus x. Here it will be x plus 2. Clear? Sorry, my mistake. It will be minus x plus 2. Or I can write it down in this way. X e raised to minus x 2 minus x. Okay. Now see here, value of e 2.17. So whatever power it is of a positive number, this will be always greater than 0. That means e raised to minus x is always greater than 0. Now we remain x into 2 minus x. Okay. Now if I take option A, let's take minus 5. Then this will be minus 5 into 2 minus 5. Clear? So minus 5 into minus 3. This will be greater than 0. But if I take plus 5, then 5 into 2, sorry, my mistake. When I take minus 5 into 2 minus 5, 2 plus 5. So minus 5 into 10, it will be minus 50 less than 0. So it is not increasing. So option A gets cancelled. Now moving to option B. When I say option B, then minus 2 to 0. That if I take any value between minus 2 and 0, right, let's say minus 1. So x is minus 1 and this will be 2 minus minus 1. So plus 1. So 3 into minus 1 minus 3. Okay, so that is also less than 0. So option B is also cancelled. Clear? Now 2 to infinity and 0 to 2. Clear? 2 to infinity and 0 to 2. Let's see option C. Let's take x equal to 3. So 3 into 2 minus 3. 3 into minus 1. That is less than 0 minus 3. So option C is also cancelled. So D is the correct one. Okay. You can also solve in this way that as it is increasing, f dash x must be greater than 0. Okay, that means x into 2 minus x must be greater than 0. That means x and 2 minus x both are greater than 0, or x is less than 0 and 2 minus x is less than 0. If this is the case, x is greater than 0, and this way 2 2 minus x greater than 0, that means minus x greater than minus 2, that means x less than 2. Okay, so x less than 2. So 0 to, sorry, it's 2. Between 0 and 2. Okay, so this is option D. Clear? If I want to take here x less than 0, and in this case it will be x greater than 2. So there is no such number which is less than 0 and greater than 2. So not possible. So 0 to 2 is the correct answer. Okay, so this was about question number 19. So just note it down. Okay, students, so that's it for today. Thank you.